actually, I have discussed with some students last night, and you guys may have confusions about the programming, especially the thinking process, right? So let me use the homework 1, the problem 3 as an example to show you what is the thinking process of a programming, right? It's not about whether you can type characters faster or slow. It's more about your thinking process. How can we think? When you read the homework, right? How can you split into different parts so that every simple part can be solved very easily? In the lectures, when I talk about the making copies, I use an example. Right? I believe you guys don't have many notations on that. So, but for this one, I believe this one already touches you for a long time, and I believe you will have a deep impression about this one. So I will use this one as an example. How I would divide these problems, how I would split it into simple questions. All right, let's log in. Right, we will start with this one, and let's see, what will be the first input? First input will be the number of rows and the number of columns and the number of operations, right? We can define some variables like that. So we can have an integer, number of rows, number of columns, and number of operations, right? Then we can see in rows. Yeah, let me use 2 hands. All right, this is integer 2. And the next one is, this, assuming this is the board, right? N by N or anything, and every starting when we started, it's painted with dot. So we can initialize a vector with all dots, right? We can have a vector of character, right? We can call it our board. This is something we are starting with. And it has rows, and each one is an element of vector of characters, right? It has number of columns, each one is a dot, right? So this one initialize our board with all dots, number of rows, number of columns. And what we wanted to do is actually we want to implement a function called a paint, right? We want to paint on this board, and then we want to print this board. This is what we mean by dividing this problem into smaller problems. Right? If somehow someone gives you a function that will print on the board, and then somehow people will print out everything, then we're done, right? So next question is, how can we implement these 2 functions? Is it clear? Yeah. The question is, if someone already gave you a paint function, if someone already gave you a print function, then you are done, right? So running main functions is very easy, right? You are assuming other people are giving you the correct functions. So next, what will be the easier function to implement? It will be this print, right? Print will be much easier to implement compared to the paint function. So let's write the print one. what should be the type of the parameters? What should be the type? Vector or factor, right? And it should be a constant reference. Because our print function, we don't want to change the vectors we have input. So we will put it here. And we will put a reference, put a constant. Right. This will be our print function. We will accept this board, but make it a constant reference so that our print function will not unintentionally modify it. Right? We don't want to modify it, but we don't want to copy data because it's a reference. We don't need to copy all the data inside the board. We just use a reference, give it a new name. Right? Then we can start to print. And about print, we just do a for loop. Right? We will iterate starting from 0 to the size. And inside the loop, we said we will print row I, right? And until now, it's very easy, right? And how can we print row I? This is how we print row I, right? Order I is the row I, and order ij is the ith column, j is the row, so we can seal it, and it's done. Right. One more thing is, after we print each row, we need a new line. So we, after print row I, we need to output a new line. Right, so this is how we implement a print function for the two-dimensional array or two-dimensional vector. Is it clear? Right, easy to see. And the question is, how can we test it? Without implementing this print function, a paint function, we need to test it. So we can comment this one out. Let's see if this print function works correctly. We need to test functions one by one, right, before we implement all the functions, so that it will be much easier to test. So we can save it. Let's see. It asks you to input the number of rows, number of columns, and number of operations. 4, 5, 4, right? It print out all dots, 4 rows and 5 columns, right? We have already verified that this print can work. And after that, we will implement the paint function. Paint function is slightly more complex. Let me write it down. So as you can see, the parameters are slightly different from the previous one, right? In the print, we don't need to modify the board, but in our paint, we need to modify it. So we will get a reference here so that we can modify it. We don't want the constant, right? So after that, we can say, all right, if I need to implement this kind of functions, what would be the input? The input would be four numbers, right? One is the row, one is the column, then what is A? A is the color, right? A is color, then the direction. So we can define variables into row. 。 right? This is what we can do. We can input row, input column, input color, input directions. And because this one there are n number of operations, right? We need another one, another parameter called number of operations. Number of operations, right? People will give it to you. And in this print function, we put the ops here so that it can be copied here. And we will put this one into a for loop. Right, in each run, we will read in the rows, columns, colors, and directions. And further, we assume, what if other people have already implemented another function? Right? Paint. Right. So in our paint function, what if other people have already implemented a paint once function? It accepts the row, column, color, and direction, right? Then this paint function is done. What we deal with is just accept the input and look at for a number of operations and call this function, right? All right, one more. I need the board. I need to change the board. All right, this is the function. And next, we need to implement the print once function. Print once, print. And we can also test it. We want to test the paint function. How do we test the paint function? We can put something in here saying right? So in our paint once function, I just want to output something. I would assume someone already implemented everything. So if I want to test the paint function, as long as it's calling this function right, I'm done, right? You can test it. Now, all right, let me recompile and then test it, right? 4, 5, 4. And what's next input? All right, let me put it here. 1 to AR, 1 to AR, right? It says here. Let me move it to the right. Print once function here. Print once function is called with the input 1 to AR, right? It is exactly what we want. As long as the paint once function implemented correctly, our functions are correct, right? And also we can verify, is it loop number of operations or it is more than the number of operations, right? We can continue typing in. I should use a new line, but anyway. 2, 3, B, U, right? And 2, 2, wait. 2, 2, X, D, and 3, 5, T, L, right? It's done. So it exactly calls force, right? It matches what we want. Loop it for a number of operations. Then it means paint function is implemented correctly. Right? So next we need to implement the paint once function. How do we implement paint once function? It really depends on the input, right? The input is a, let me see. Right? It really depends on the directions. If the direction is R, we do something. If the direction is U, we do something. If it's P, we do something. If it's L, we do something. Right? And let's further assume someone already helped you implement another function called paint. Right? If someone else already helped you implement another function called paint to right. And we need the start position. Yeah, we need the board. We need the start position called the row, the start position column, the color. And we don't need the direction anymore, right? Because we already know direction is to the right. Yeah, let's save it. And then we can do similarly. Have another two functions. If it's U, we say paint up, right? If it's D, paint down. If it's L, paint to left. It's okay to write as many functions as you like. As long as you are making the code more readable, it will be fine, right? So from our perspective, paint once is done, right? We only jump to some functions based on these directions. If it's R, we call some functions. If it's U, we call some function. If it's D, we call some functions, and so on. And what we need more is a break, right? We need a break. Otherwise, it will jump to the next line. So let me paste it, and then paste it. So here, we might need another one called default, or maybe not, I don't know. Let me put it here. Default just break, maybe not needed. Let me first put it here. All right. So paint once, right? How can we verify paint once is implementing correctly? We can have another function called paint to right, paint to the left, up, paint to down, and so on. Let me do that. Oh, yeah, the two need to be capital. Yes. Right? We can do something like this. In our paint to right function, we can just see out something so that we can verify it's paint once correctly. Let me delete this line and can we copy 4 of them? Okay. 4. Let me just delete 2 of them. You guys know what I mean, it's fine. Let me use 2 as an example, into up, right? I will delete this 2 just for now, because it will be tedious to write all of them. All right, so I have implemented paint to right and then paint to up. I want to verify the correctness of paint once. I want to verify paint once. All right, let me see. Right, instead of calling paint, you can do what you like is, I want to verify paint once, because I know paint is correct, so I don't need to verify paint. Right? I can verify in our main function. I don't need to call paint function. I can call paint once function so that I can verify paint once is correct. And we can do it. What we can do is compile it and run it 454. Right? As you can see, paint to right is called paint to right is called with 00A, and paint to up is called 00B, which means paint once function is implemented correctly, right? So I did step by step, and then we will care about how to implement paint to right, right? This might be the most complex one. Let me see. So what if we want to do it manually, right? Instead of using a for loop, we could say something like this. Right? This is something we would like to implement. What it means by paint to right, right? Row column is the starting point. Row column, paint to right means this element painted to some color, then the right one painted to color, then the right one painted to color until the end of this row, right? So this is something, if we think in our mind, this will be the process. And how can we make it a loop? It will become a for loop. Right? This is what we needed. Starting from the column until the end of this row, we make it this color. And now we can delete this function, this output line, right? We are done. How can we verify this one is correct? Again, go to the main function, right? Instead of paint to once, we test if the paint to right is correct. Paint to right. We no longer need R. Then test again. Paint to right. Maybe 1, 1. Right, this is what we want to print. And we want to verify after each operation is correct. So what we do is we paint to right, starting with 0, 0, and with color A, we print to the board. Then paint to right, 1, 1 with B, then print the board. We want to verify if this function is implemented correctly. So we can, right. This is what we will verify. All right, let's go to the left side. 4, 5, 4, right? 4, 5, 4. First, we print to right, starting with 0, 0, and with all A's, right? Starting with 0, 0, and all A's. The first row are colored with A, and this is the output. Next, we paint to right, order with 1, 1, with color B. We're starting with 1, 1, right? 1, 1, and to the end of the second row, all of them colored B. So by this way, you have implemented the paint to right function, and then you will be maybe 9% sure paint to right should be right, right? And for all the others, you can do the same. Every function like the paint to right or paint to up or paint to down, they only need a single for loop. Right? So for this single function, you verify it's correct. Then you go to the paint once function, because paint once function is just calling these functions. You have verified it's correct. And then you can look at your paint function. Your paint function just reading row by row and do a paint once, right? It's also correct. Then you know if you go back to your main function and then change it to paint, your functions should work correctly. So this is how you, this is basically your thinking process. Working on the problems step by step, right? Solving something that's very simple to solve, like the print function, the print board, then go to some harder questions, then making them a smaller and smaller problems. And each smaller problems will be very easy to solve. It also improves the readabilities, right? If you're writing some code like this, even without comments, I would basically know what you are doing, right? Because every function only do one thing. For the paint once function, it will do one thing, depends on the direction, call some functions. In the paint function, it's just a loop, right? And reading in the number of the commands, and then you can do paint once function. So every function has its very specific functionalities. It's easy to read, it's easy to verify. This is how people write in codes. And in the future, many of the functions will be writing in a separate file, and each of the functions need to be verified independently. It's called unit testing. You need to test one function by one function. As long as the functions are working correctly, you can combine them together. All right, any questions? It may be tedious, right, compared to if you put every code in just one main function. You are writing more code, but it's more clear in your mind how to solve the problems, especially when you are working on larger problems in the future, especially in your project. This process will help you. No more questions? Then we will come back to our class. Wait, where are we? No, this far. All right, let's go to arrays. So last time we have talked about the vectors, and the vectors are the preferred type you should use for something like the arrays or a continuous data that have the same type. But arrays are the C style or the more lower level implementations of a vector, actually. So if you look at a vector, if you learn about a class in the next lectures, you will know they will hide the array implementations inside your vectors. And so because of that, factors will be a little bit slower than the original arrays because you are putting more things outside of your array, right? You are grouping the size and many functions together with arrays, and they becomes vectors. So you will still see many programmers using these arrays, and the difference between that is arrays cannot be resized. So the vectors, right? If you want to resize, you can call some functions, or you can do a push back, right? Whenever you push back, the size will increase. Whenever you do a pop, the size will decrease. But arrays, you cannot, it cannot be resized. And let me see. Arrays are faster and more efficient than the vectors, right? If you want your code to be faster, if you care about this amount of maybe microseconds faster, then you can use arrays. But it's more dangerous to use than vectors. So how can we declare an array? So this is how we declare a vector. These two are exactly the same. They are continuous, they have 10 elements, and their type are double. Each element of salaries are double. So this is the way you can define an array. Put a data type here. So if we want to define as a single variable, we call it double salary, right? But if we define an array, we put a bracket here and put the size here. So this means we define 10 numbers. They are all double type. And we said how we can never change size. So to get the size of an array, it's a little bit tricky. You will find out if you use the same way in a vector. You could call salaries.size. But array don't have that. Arrays, these names, if you learn the pointers, you know the name is just a pointer. So it's different from a vector. And this one, if you want to get a size, you can call size of the salary divided by size of a double. But it will not, it might doesn't work, right? Sometimes it might fail, especially if you are passing your arrays to some functions. We will show that later. So it's more tedious to use arrays. So in the old compilers, old standard, the size of an array need to be known during the compile time, right? You can say a constant, you can define a constant salary capacity, and you can define something like this. Or in a more stringent way, constant instant cannot be used. They can use something called constant expression. But anyway, this number needs to be fixed. But nowadays, when you are working on the new compilers, they don't care about it. What they can do is, let me show you. What they can do is, let me jump out of it. Let me have a test. What they can do is you can see in a size. Then you can define an array such as the salaries, right? The size is what you have specified. So in new compilers, it's also supported. But I wouldn't suggest you do it that way because many of the older programmers or experienced programmers will say, okay, this is not valid. Sometimes they will tell you that. Because in the older styles, it's not valid. Size need to be known during the compile time. That's what they have learned during their C class or C++ class. But anyway, it's doable. But how can we initialize an array? It's very similar to vectors. If you guys can still remember vectors, you can do similarly. A factor of salary equals braces 1, 2, 3, 4. Right? It means you are defining a salary with size 4, and these are the elements. Salary 0 equals 1.0, salary 1 equals 2.0, salary 2 equals to 3.0, and so on. And then you can also define something like this, right? You know the size, but you only initialize the first one. It's also fine. This is how can we initialize an array. And in your program, you always need a constant or at least a variable to keep track of the size of an array. That's what we will know later, and we call it a companion variable. So let me see if we have an example for that. Yeah, for this one is the old one, right? We have learned a vector, or the one we learned during the last lecture. We define a vector, and what if we want to iterate through all the elements of this vector? We say I starting from 0, that's then salary dot size, and then we can call salary brackets I, right? Because we have this one, salary dot size, that tells you the size of this salary. But for array, let me see if we have one. No, maybe later. Yeah, here. So in here, right, we need a variable called size to keep track of the current index of an array. So the question is, how can we rewrite it in a vector version? This is what we will do. We can read salaries one by one until 0, right? And when it's not 0, we will put it into the salary arrays. How can we translate these two lines into a vector version? If it's a vector, how can we write it? Yeah, pushback. Salary dot pushback x. Right? We don't need to increment the size. We don't need to keep track of it. And if you are passing arrays as a function parameters, not only you need to pass the array name, you also need to pass the size. And passing the array name can be this way or that way, like A brackets or star A. Star A means, because the array name is just a pointer, but we will skip that because we have another class talking about pointers. So you can use star A or A brackets, but this one is much easier to read, right? You will know this one is a array, but it's also fine to define it in this way. But anyway, you need to give it a size to this array.
With its reference, array's reference,
yeah.
To combine its the main and its size.
Yes, you can do that, but it's especially when the functions are written by others, right? They might not write in that way because when they are accepting a reference, it requires the initial arrays to be there, and they are so how should I say it? The more important thing is sometimes functions are written by others. Right? You cannot control how they use it. But this one is a more common way people write a passing an array and a size to it. Yeah, this is just a style issues. For example, if I do this, what will happen? In our main function, we define an array called A. Its type is double. The number of size is 10, and we can output the size of A, and also we can we define another function called get size. It will do exactly the same thing, right? Size of A. What will happen? What's the output? Yeah. Let's try it. I don't know space. So this is the function, right? In our main function, we defined an array with size 10. We call size of A. We define another function called get size, which is defined in here. We will accept this array A, and we will do the same thing, size of A, right? Let's see what's the difference. it might confuse you with the output. Let me cut. Yes. Wait, some warnings. Can it run? Yeah, it can run. Push it up. Close it. All right, we can compare it, right? First time when we call size of A, we got 80. 80 is because each double 8 bytes, right? It's 8 bytes, so 8 times 10 equals 80. But when you are putting the size of A, putting into a function call, inside a function, right? It will return 8. Yeah, it's the size of the pointer. It's the first element you can think. Yeah. So that's it's confusing, right? They are doing exactly the same thing. Size of. The only difference is putting into a function. Nothing different. So that's why you need to put a size here, right? Whenever you use a array as a parameter, it's better to give a size here, right? So that people know what the size of your array. Any questions on it? That's the difference between array and a vector. When you call, if it's a vector, this one's a vector dot size, and if you put it into a function called vector dot size, they will be exactly the same, right? Let's see. Look at this one. We can have another. All right. Let me try it. Oh yeah, this one. Size B. All right. So as you can see, we do similar things, right? If we define a vector, we call the size, it will give you 10. If we put it into a function called b dot size, it still give you 10. Right? So that's the difference. If you want to, this is how we can get array to size. Array don't have a built-in function called something like the size. They don't have it. That's the only way we can get the size of an array. Mm-hmm.
There is a function to get the size of an array.
What's that called?
The standard size.
Standard size, STD dot size.
Yeah.
Okay. Yeah. Maybe there is.
But it can't take pointer as its parameter.
Yeah.
So you can only use standard size in main function.
Okay. Good. Got it. So this is the confusing part, right? When you are learning about arrays. So that's why we would suggest always use vectors. Always use vectors if you can. Because the performance issues is not that different, like this one versus this one, but it's more easier to understand. Any questions? All right, let's continue. Why this one is always here? Come up. All right. And you can try out of bound access, similar to last time we do for the vectors, right? You define an array size 10. You can try to access the 100 elements of A. Compiler will not complain. You can still run it. Sometimes you will fail, sometimes you will success during the runtime. Depends on the whether you will get a segmentation fault. Right, so this is sometimes the better way to use an array and combine it with its size, right? If we want to call a function that accepts array, always give it the size. This is how we do it, and we can iterate from 0 to size and change each element of this array. Okay. Even if you put some 10 here, you cannot use the 10. But what do we mean? Right? Remember here? See this function? Even though I give it a 10, right? It doesn't output, they don't know A is size 10. This one doesn't matter. If you put a 10 here, or 1 here, or 2 here, it doesn't matter. It's just a pointer to the first element of an array, and they don't know the size. So typically, what we write is something like this: an empty bracket, right? Empty one. You don't need to put a size here, because compilers will ignore that. And if you are trying to keep it constant, you put a constant here, similar to the vector one. Okay. For this one, we have already said this one is a incrementing the size of an array, right? But while you are reading more data inside these functions, the size of the array is changed. So how can you get back the size in the function that calls this function? We should use a reference here, right? If you are trying to modify the arrays. So after this one is done, the size will get the exact number of elements inside an array, right? But if it's a vector, you don't need to do that. If it's a vector, after you modify the vector, you just call the vector dot size. It will give you this number of size. But for an array, always keep in mind, whenever you add more data, you decrease more data, you need to change the size. How about return an arrays? Typically, we don't return an array, or because it itself is a pointer, right? You can directly modify this array. You don't need to return it, but you can also return it. Just keep in mind that there will be some scopes inside. If you define an array inside and return it, it will be some address that they cannot access. But that we will leave that to the pointer lecture. That's more complex than that. So there will be some problems. But this is how we can return an array. You can return a pointer, right? This way. Remember, array name is just a pointer. You can return a pointer, and then you can do something like this. But it's not suggested. You can do anyway like that. For the arrays, for most of them, for now, just need to know them, know how to use them, and that's it. You don't need to use arrays anymore. You can always use vectors. It will be fine. So I will be very fast to do that. How can we resize an array? How can we resize a vector? Right. Resize an array isn't so complex. You need to dynamically allocate a new bunch of continuous data for this array. Also leave that to the pointers class, and also resize vectors, easy, right? Vectors push back, pop, resize, and so on. Yeah, And you can also write a piece of code to check how the vectors will resize if you will push data one by one. What do we mean? It's like this. This is the size, right? Change each time because whenever you push a new one, it will increase the size. That's a typical vector would do, right? And the vectors actually have another one. Let me see if I have it. I don't remember, maybe max size. Let me see this one. Did this one work? Max size. All right. Oh, not this one. Capacity? Yeah, maybe the capacity, yes. It's called a capacity. Yeah, capacity, right? It's hard to see. Let me comment out this line. This is how vectors will do. Whenever you push back, they have a capacity. For example, initially, maybe it's 0 or 1. Then whenever you push 1, let's use this one example. Initially, the capacity is 1. So you can think of vectors contains an array, size is 1. How about you want to push another one? Right? How about you push another one? They will dynamically allocate a new vector, size is 2, so that you can push another one. How about next time? When you push a new one, right? You need the size 3. They will double the size to 4, and then they will push the next one. And then whenever it goes to maybe near 7, they will double the size again. So the capacity of a vector will be doubled each time, so that it can push element one by one. So for the remaining ones, for the vectors, right? If for example, if you are here, when the capacity is 8, at this time, the useful elements are only 5, then 6, then 7, then 8. Right? There will be some empty space in a vector. So that's inside the vector, how they do the work, right? Inside the vector, these are the size of the real array inside. That's encapsulated inside the real vectors. And that's what they will do. That's only something that you need to know. All right. So enough about arrays. Arrays just, I will go over it very quickly. Like I said, you don't need to use it because it's the only way. So for the strings, right? We have mentioned about the strings, something like the hello. in our first class, we defined it as a string. We can also define it as a character array. Right? It's just a bunch of characters. We can use an array to keep them one by one. The first element is H, second element E, third element L, and so on. So this is the actually old way in the C style of defining a string. Right? This is how we do it. And as you can see, the difference is if we want to define a character, single quote, define a string, double quote. Is the difference. And what's the size of an array, of an character array? Hello has 1, 2, 3, 4, 5 characters. But when you define the greetings equals to this, the size is 6. There will be a terminator at the end, \0. That's not printed. But that's to specify, okay, that's the end of a string. Especially when you want to print it, right? We want to print it. How the machine know it's the end of your string? They will read one by one until they see a \0. So they will keep that in your character strings. So whenever the size is 5, you are adding one more size to it. This is what it looks like in the machine. If it's put in your machine, it's like the first one is H, then one E, then L, then L, then O, then \0. And you can get the length of your string using the string length, strlen. Right, this is the length of your string. It will count how many characters you have until the last one, and now the \0. Again, this is not the suggested way to define a string. The suggested way is still using the string type in C++. But this would be the old one that in some old code you will see how people will define strings like this. All right. And here is similar to arrays, right? We can put a name, array name to a parameter of a function. But remember here, we don't need the size of our array, right? Because it's a string. We know when as long as we can see \0, we know it's the end of our string. Right? So that's the difference between this one and the typical arrays, because we have a terminator, right, telling when this will stop. So you don't need the size. Yeah. So when people tells you, okay, define a string that will be 10, it has 10 characters. Always remember +1 here, right? Because you need to store the last now character. Right, so here is an exercise. Implement a function to convert all characters in a string to uppercase, from lowercase to uppercase, assuming it's only have letters. How can we do that? maybe not easy to write it. I will convert it just in place instead of creating a new one, right? So this is the function we need to write, called toUpper. We start with the lowercase hello, and we call toUpper, then print it. Right, this is a typical way, right? You can do it, and let's implement this toUpper. Right, first one, what we can do is we can use the while loop to see if we reach the end, or the other way is we can get the size directly, right? Let's first test, is string length still working correctly inside our function? So let's say compile, string length not declared. Yeah, well, let me see where is the string length. C string. Yeah, I need to include this headlines. Right, it's working. Right, it's still workable. Right, the size is 5. As you can see, the string length of string is 5. It's different from what we say string has 6 elements. Right, string length will give you the number of printable elements instead of the last one. So as you can see, the string length will output 5 instead of 6. After verify string length can work, what we need to do is we need to convert to uppercase. Is it less than or less? Less than equal, right? It need to be less than equal because string length, wait, it is less than, right? If it's 5, yeah, less than. You need to consider that. Plus plus I.
Suggested that we should use a variable to store the operation. But not don't call string length for many times.
Yeah, it is true if you are using these strings, but for the character arrays, you can actually do that way sometimes.
I mean, in this way, it will be slower. It will be slower. Yeah.
It will be slower than what?
Yeah, you should use a variable to store the length of the string.
Yes, you are right. Because each time when you call this function, it will be, yeah, it is true sometimes, but yeah, because it's not constant, so it's not a constant number. But let me just show you this way, all right? And after this is done, right, we need to translate each element inside here, right? How can we convert string I to a uppercase? So what is string I? It's just some character, right? And how can we convert character from lowercase to uppercase? We can read the ASCII code, right? Lower A and upper A, what's the difference? Lower B, upper B, what's the difference? Lower C, upper C, what's the difference? the difference is a fixed number. If you look at the ASCII code. So what you can do is very simple. Minus, I believe, lower A is the, yeah, lower A is the larger one. Right, you can do something like this. Is it doable? Yeah. Right. Lowercase hello becomes uppercase hello. So this is the what we can do. So what is lowercase a minus uppercase a? We check the ASCII code. Sometime. Right. So lowercase a is 96, uppercase a is 65. So lowercase a minus uppercase a equals to 39, right? If you are a B, B equals 98. 98 minus 39 equals 66, which is uppercase B. And similarly, because every uppercase A, lowercase a, uppercase B, lowercase b, their difference are a fixed number, right? So you can translate, you can convert from uppercase to lowercase in this way.
Check this figure. It's not already uppercase, right?
Yeah. Yes, yes. You need to check if string I is in the range of uppercase A to uppercase Z, right? But we would, in our homework, we would assume everything is valid. So, any questions on it? This is how you can work on a character array. No questions? All right, let's come back. How can we do concatenation of two character arrays? Think in mind. I will leave it to you to implement that. Maybe you can ask ChatGPT to do that. It's much easier. All right. Let's go to the two-dimensional arrays, similar to the vector, right? We can write two-dimensional arrays by two brackets. So it becomes ours. It has number of rows, number of columns. It will be very similar to vectors. So if you want to arrange it in this way, so this is number of rows, this is number of columns, right? And everything starts with 0. So ours 34 means the 4th row, 5th column. This is the how we define a two-dimensional arrays. And indeed, how they will arrange in our RAM, in our machines, they will put row 0 first, row 1 next, row 2 next, row 3 next. They will arrange it row by row. This is how they are stored in our memory. And if you want to pass in a multi-dimensional array to a function, you must have the bounds for all dimensions except the first one. First one could be empty, but all the others you need to give them a size. It's a very weird way to write, right? Yeah. So it still suggests to use two-dimensional arrays using vectors. But anyway, this one can still work, and you can see exactly the same way, right? Iterate from 0 to rows, iterate from 0 to 10, then outwards. You can try this code, constant double, two empty brackets, compilers will complain. Because compiler need to know how to arrange it in the memory. But I can try it. I believe that's the end of the arrays. All right, let's take a 15 minutes break.
I don't get why is this 8? Is it because it's taking the size of the very first pointer of the array, which is 8-bit, and then this one is taking 8 times the 10.
Yes.
So not actually giving you the real size. I see.
我也是不太懂那个问题。
就那个 size 嘛，就是你交给了那个函数以后，函数就不知道你的大小是多少，它只知道你第一个元素是大小是多少。
第一个是10，它就知道是10。
就是一个 double 的 size。对
，double 就是8。
对，
所以它就是 print 8，然后是次。
只一次就够了。
一次。
对。
那为什么它那个直接用是80？
就是在主函数里面，因为它是知道大小，所以它能够直接给出一个大小。但是在函数调用的时候，它就不知道你的 array 大小是多少。
那它给的不是它的 size 大小，而是它的就是
元素第一个元素的大小。对。
为什么那80它算的不是它的位置？
对，80字节嘛，8个字节。
那如果是 vector，它那个 size 就是元素的。
对 ，vector 的 size 就是元素的个数。还有点不太一样。
就是它要是写一个 double A， 然后毛10是啥意思？
没有用的。就那个10放在这和不放在这是没有意义的。因为 compiler 它不知道这个地方 size 是多少。
那它咋理解这个
10吗？
它
不理解，它就把10去掉，就变成一个空的，就跟这个一样，就知道它是一个 array。
行，这样。
对。
老师，我们交作业的问题，就是我交了很多遍，然后同一个文件的话，再问他们加-1-2，就比如说本来这个是对的，然后我以为我自己改了名字，然后我再交了一遍，然后加
没关系，这个-2没关系，-1-2没关系。
但是我实际上。这跟这个是一样的，我以为自己改了名字。
你说你 late 是吗？你可以找 th argument 就一模一样，到时候你让他 regrade 就行。
老师就是做作业，他在丢之后交换。
每天扣分，每24小时扣5分至少。所以你算下，经过了3天、4天、5天，你可能就只剩下70分、60分、50分，就这样子。对，因为你当时教我们有一部分的分是，比如说 readability 的分，有一部分可能是其他的分，可能你已经能拿到，比如说，即便你交一个比较差的文件，可能也有30-40分，但你后面交的话，就每一次要固定的扣5分，比如说
就是总分吗？
对，总分上。
而那个考试的话是笔试吗？
笔试，对。
就是为什么大写 A 跟小写 A 中间的码差了32位，不是16位？
就是 ASCII 那个规定，它在大写 A 和小写 A 中间又加了一些什么括号啊、斜杠啊。
就是那我是不是可以在那个直接就是把它的从右往左数的第5位直接0变1， 1变0就可以完成大概？
从右往左是几个意思？你就是说把它转换成二进制嘛
？2进制的0变1， 1变
0。可以。
是哪一个？
就是把比如说这个转化成2进制，65转化成2进制，97也转化成2进制，你会发现它们就是某几位不同，有可能是可以的。对，可以用2进制来讲，但是这样子写很不友好。
不友好。
对，
看不懂。
对，别人看不懂。
但是这样快呀。
快不了多少，真的。
它原操作也没有。现在基本上你汇编行数差不多，那就
对，是的。
对，老师，有个数组的时候，比如说本来是 AI 表示数组 I 的，不是数组 A 的第 I 一个位置嘛。然后我试了一下，把它改成了 I 括号中括号 A， 然后也是可以过的。
可以啊。
什么意思 ？A 中括号 A 是吧？
对，你有 ARRI 和 IARR 是一样的，就是
A。
然后多维数组就不可以，
这样子吗？
不是中括号。
中括号，对，这样子。
对，然后把它改成
IARA， 对，可以的，没有问题。
就是一个 I 一个 A。
I 中号 A，
中号 A，
中号 A，
它就是数组它的这个数组的本质指针你应该知道吧？数组本质是一个
这个后面
密
会说，
制常量，
但是这个我好像没怎么见过。
但是就是
中号
A 中号 I 它做的是一个什么操作呢？
不是 A 加上 I
对呀
乘一个
它是这样的，就是它做的是这样一个操作，就是解引用 A 加 I，
对，
它做的这样一个操作。所以说你把 A 跟 I 颠倒过来，就相当于在这里边把 A 跟 I 颠倒过来，所以它俩是一样的啊。
应该是可以，
对，可以的，就是
数组就不行。
多维数组，
多维数组你要
多维数组，
你要把它写指针的形式，你再试一下。应该不
可以，你应该是你的数组名和你第一个
你要知道大小，你要知道大小才行，因为你要知道第二维的大小
啊。
这个时候就不太一样。这个不要 confuse 别人，对，不要 confuse。
这样只会让你的代码变得抽象。
对，这样代码太抽象。代码更重要的是可读性，可读性是最重要的第一位。对，你写的再长没有关系。
然后有什么方法能够就是在一个二维的空间里面，每一行的长度不一样？就比如说第一行1、2、3，第二行1、2、3、4、5。
可以 vector 是可以
用 vector，
是用
vector，
因为 vector 是相当于套 vector 里的套
对 vector 里面套 vector，每个 vector 都可以不一样的 size。
那我输入的时候就可以一行一行输。
对，可以
输入一行一行输，然后往里 push back 就行。
是的
啊。
你们内存会浪费吗？还是
不会浪费，它就是连续的空间。
这么抽象？
对，它就是连续。
它那个它数组的character 类型是不是可以直接用那个 string 去平替？
对，完全可以平替。
可以，
基本
效率会低一些啊。
对，速度慢一点，就跟 vector 跟 array 一样，速度慢一点，但你可读性强了。对，
其实就是那个动态分配数组的那个，它并不推荐的另外一个原因就是它没有办法进行模板操作，就包括引用和模板都用不了。
对，
因为我记得有一种就是你把数组的那个长度也在函数里边封装进去的这个一个方法，就是比如说我 void f， 然后里边用一个 auto， 然后这样一个 ARR 的话，
可以。
对，如果你在这里去用 size of ARR 的话，它跟在外面一样的。对，因为它把引用传过去。但是如果说你用那个动态分配数组，它是就这个函数就调不了，这个函数根本就调不了，它不能被引用。
对，是的，
就是两个 end
两个 end 是右指引，这个
太
对于类型来说是右指引用，对于 auto 来说，它叫万能引用。
不是，size of 可以用在任何地方。
size of 是一个运算，
对，
那这里区别是什么？这里的区别是，如果你传一个普通的数组过来的话，它会退化。
对，它没有
化成
一个指针，
所以 size of 它就是 size of 指针。
函数拿出来就是一个
固定是4或8了。
对，4或8，要么4要么8。
在哪里来？那个东西就尽量不要去。你要想得到 size， 你就给一个参量就行了。
就外面先把 size 算出来，
对，
函数输入只多一个 size。
对，你就函数的那个参数多一个而已。
那像那个二维数，你刚刚说我们在定义函数的时候，输入一定要把第二位就是列出。
对，第二位给它列出去。
那我可不可以直接星号加上数组名称？我问了一下，
如果是二维的话，你要2个星号。二维的话，你用2个星号就可以了。
就是我输一个ARR 空括号，然后中括号10
啊，这样
就可以平替成2个星号，然后 ARR 还要2个星号。
你二维数组2个星号，3维数组3个，有没有3个星号？没怎么见过。没有关系。这个
函数是一个要传个2维数组进来。
对，你就告诉他要传个2维数组进来。但是现在你们先不用知道这个，就在研究指针那一节的时候会讲到，指针就是比较复杂的一件事情。对，
我们到时候会不会学系统学习字符串？我感觉字符串好像它还是有很多那些什么。
对，我们有一章讲 string， 有一章讲 string 的。
我看到 class 后面就是 string。
对 ，class 后面是一个 string。class
是哪个
？class 就是下堂课就是讲 class。
哦，在那个大纲里面有。
对，大纲里面有。
下一节课讲。
啊，现在就讲了。
好难的。
这堂课就是应该讲递归的，就是我要把前面的赶紧结束掉。
上面的 S size。想问
好
这样可以就不是我们有作业吗？可以在 OJ 上面摆一些就我们作业，然后可以测试我们代码，就可以让我们知道自己的代码是对的，不然交上去如果错了我就
对 OJ 上不是可以吗？
你只有个 painting，我看 OJ
哦，
只有个 painting，其他2道题没有。
哦，这样子啊，
那个哦，
我不知道他们到底。
所以说我每个测试作业都是要把那几行的输入全部，那你全部输一次，那也就只有几行
啊。
如果还是
就是这个 get size 是我写的一个随便的函数，
对的，其他
对吧
错的。
这函数名不重要，但是这里面调用了这个东西，就我的意思就是你在函数里面调用 size of 跟在主函数里面调用 size of 就是不一样的。这里呢，它是知道它的 size，所以它是每一个 double 就是8个字节，那么就8乘以10就是80。但是你调到一个函数里面去以后，你传过去的只是它的指针，指针的话就是第一个，它只知道它的第一个的大小，所以它的结果就会是8，而不是80，就是啊，为什么是乘以10？对，因为它有10个 double，每一个 double 都是8个字节，所以它的 size 应该是一个80。对，指针后面会讲，我只是告诉你不要用 size of， 在这里不要用 size of， 然后传一个 size 过去。
还有就是有个小问题，那个就是引一个字母是不是单引号？
对，单个 character 是用单引号。
我不知道哎。然后还有刚刚讲的那个，为什么第一个有空，第二个是死亡？
这个你记住就行，这个是编译器强制要求这样子。
还有就是它那个下面那个另外一个是不行的。
对，另外一个是不行的，你可以试一下。基本上 compiler 会告诉你这样是不行。
greeting 的那个 hello 那个数。
就为什么 size 是6是吗？还是什么？
就是会有一个结束
也可以，但是6会。
我看一下在哪里来着？就这个是吧？对，它的大小是6。其实它这个6其实是它的那个在内存里面占用的空间，其实它是这个样子写的，这个样子写的。
如果没有这个会怎么样？
没有这个，它就一直 print 下去。如果
报错，
应该不会报错，
它
是很少报错，
表示字符串的结束。
对，如果你比如说某一次把 greeting 5给复制成了一个小 a， 那么它就一直打，
就一直就重复这个数组
不是重复这个数组，它就会一直打下去，一直遇到斜杠0为止。内存里面会有一堆的无聊的 noise 在里面，它就随机的数字、随机的字符给你打出来一长串，一直打到它结束为止。
这些未知的东西
对，未知的东西一直打到0为止。
如果没杠0，就系统
没杠0，它一般情况下都会有杠0，杠0就是0嘛，因为很多0在里面。其实
我定义字符串的时候会自动帮我加杠0。
对，因为你系统重新启动的时候，它的硬件里面很多都是把它归零化的，有好多。对，
那我定一个 string 变量的话，也会有杠0吗
？string 它把所有的封装里面你看不见了，你不知道它在里面，其实它是这样子的。对，但 string 如果是那个 string 的 type 的话，它是封装在里面，你是不需要考虑这些事情，它都会帮你弄好。比如说你要替换它，它就会自动的给你加一个0在后面，比如说怎么样，它就会有一个自己内部的操作在里面，你是不允许直接修改这个东西。
那比如说我是 string，然后再就定一个 string 变量，然后再比如说也是 hello，然后再就那个变量名，然后再加中括号5，然后它那个也是杠0吗？还是
它可能会报错，因为它封装在里面，它会告诉你可能 size 超过了或者之类的，你可以试一下。就是封装的好处就在于很多危险的操作它都不让你去做。
那像这个如果打greeting，然后杠5的话，就可以显示杠0吗？还是
可以试一下
杠0，
可以试一下。
get size 那边还是没有听到。
get size 嘛，
对，
就是没关系，我先让他们先问好。你什么？
对，我就不懂这样。
包括下是什么 same as， 所以
就是你可以不指定它的 size，直接给它一个初始的值。那么它就会成这个样子。它的大小总共有6个位置，1、2、3、4、5、6。它的大小其实是6，是一模一样。
那如果用 string，
用 string 的话就不需要这样 ，string greeting 等于 hello 就可以了。它自己内部会分配一个这样的东西给你，就它把它包装在里面，对，还是6个。但是你永远不会知道有6，你不会，比如说打印出来它的 size，它会告诉你是5， 长度告诉你也是5，
string 的话长度是5，但是如果char 的话就是6。
也是5。你用那个 string length 打印出来还是5。
那它俩区别是什么？
它不会，就是它把所有东西都封装在里面，它不会告诉你它的实际上还多存了一个东西，它不会告诉你的，但是实际上它不存了。
你说 char 吗
char 也是 string 也是都一样，对
但是
，string 只是在上面包了一层而已。
哦
就是你先不用考虑 string， 就考虑这个 char 这个。你定义这样的时候，它在内存里面分配了有6个，
这个
对，多了一个这个。
还有个下一页，再往下，这个，这个，
对，就是别人告诉你，比如说要存我的名字，我的名字杨迪 YANGDI， 你要存6个 character， 你要定义一个 string 长度为7。
对，那如果是刚那个 hello 的话，它应该
你要定义一个长度为6的。
所以说我写5，它就不行。
对。
那如果7，如果你
7的话，你就定义成8，长度为8。
就是如果它本来有5个，然后我定义为6，可不可以定义为7？对，就是说 hello
它就会溢出的时候，hello 定义为7可以，
可以，
大是没有关系，就是最小这个，这是最小的。
就是说你得给它6个，但是你怎么问它长度，它也是5。
对，是的。
6个。还有就是加加 i 和 i 加加，就是 for loop 里面
都可以，都没有关系。其实对你们来说
啥区别都没吗？
在编译里面是有区别，它效率上会差一点点。
就用加加 i 要好一点。
对，如果加加 i 能解决问题，就用加加 i 就好一点，但是都没有关系。有很多人喜欢 i 加加，因为这一点点的时间差他们不在乎，就几个微秒、纳秒之间的差别。
但是还有那个刚刚说 char 用单引，
对，char 用单引，然后 string 用双引，是在哪里来着？前面吗？就这个，对，就是单个变量的时候，它用单引号；你如果是一个 char 的数组的话，就用双引号。对。
然后就是它刚刚那个 ASIC 嘛，就是小 a 减小 a 减大
a 减大 a 是97减65等于32。
它用的是这时候单双引号就是它 matters。
对，用单引号就是一个 character，不是一个 string 减法。你放的 double quote 那是错掉的。
懂了。
因为单个 character 其实就是一个 integer，是一样的，它会把它自己转化成97，它都转化成65，减一减就等于32，然后你这个 character 减掉32，就你不管是哪一个减掉32，就变成你的大写。双引 string 的减法是不存在的，它会报错。对。
作业就是 const 的那个点是 print 的时候，它在用 switch 的时候就会变。应该是
啥意思？
就是作业。
就这个？你是说那个 print 函数是吗
？print 和 paint 它两个，如果 print 有了 const 的话，那你 paint 的时候为什么就能 paint 出来是 a 或者？
这个是这个函数，这个是2个单独的函数。这个函数里面 board 不是一个 const， 这个 print 里面它是一个 const， 它只是告诉你这个函数不能去动我。
它会覆盖什么？
不会覆盖，没有覆盖。
那它怎么就是2个最后 paint 出来的是？
因为这2个函数里面用的东西是不一样的，它是 board 是引用了那个东西，
对，它都是一个引用而已，它是一个 const 的引用。就不管你主函数里面是什么样子，我不去变的。
其实它这个 board 和那个 board 和最后那个 board 是不一样。
对，都是单独的变量名。我可以把它名字都叫不
相同，
它叫 B1， 它叫 B2， 它叫 B3，都是可以的。
这他们不是真正一样的 board。
对。
它不意思不是说借用原来那个 board， 然后
对，
把它修改。
但原来那个是可以修改，跑到你的函数里面就不允许修改了，
因为你 const 了。
对，你
这个是不能修改。
对，这个是不能修改，但跑到这个函数里面又是可以修改的。
就把它 dot 换成。
对，就取决于你这里有没有把它变成 const。